This is a demonstration about filling the FEFLOW centroids for a fully unstructured finite mesh which is pre-created. The mesh we're going to work with is one of the Alpine model, and I'm going to load it now. The objective here is to add geological information coming from the GeoModeller model. So here we have the finite element mesh, which is fully unstructured. Showing now. What we have to do is go to user data, right click, add elemental distribution and call it geology from GeoModeller. Then we need to right click on that user data, new user data element, export the data, all elements as center. Give it a name of centroids. And it will export as an ASCII table. When that is complete, we can minimize. Let's open GeoModeller. We need to open the Alpine model, which has the same geolocation as the finite element mesh, and I will open it now. What's existing here is a low resolution model. Let's remind ourselves, this model is based on raw data from which is constraining the implicit model. We'll just hide that implicit 3D model now, and under grids and meshes, our objective is to import the centroids.dat file, but first of all we need to change it to CSV. And now we right click the grids and meshes field and we import those as points. Opening the points will cause a wizard to operate. We need to click for space separated and to treat consecutive delimiters as one. It parses correctly and go next. Now we need to select the columns to import and treat them as a field other than X, Y and Z. And finish. The progress bar indicates the large file is still loading. The plus signal indicates the centroids have now loaded, and these are all the fields of the parent mesh. So what our aim is to add the current model field to this point mesh. So you'll remember we had a low resolution model built, but just to prove that that's not going to be the one that's going to be sampled into the points mesh, I'm going to compute again, which will blow away the model. So we have to select all the series to interpolate. There are no faults in this model. We're selecting data on all of the sections to take into account for the compute. That blows the model away. There's no more plus sign there against the built or visualized 3D geology, but there is a mathematical solution precisely held in memory and solved, and that's what's going to be sampled. So if I go to the parent mesh and right click, you can see this function called add current model field. It's going to query the geology everywhere in 3D space, and then it's adding a field to this parent mesh. It does take some time. It's a rather large mesh, and then there it is. We're popping it into the new field. So let's visualize that now and get ready to see. And its points. Let's view it in 3D. There it is. So these are the informed centroid locations, informed with geology, and the colors are coming out as expected, and now that's ready to bring into FEFLOW. So bringing those back is a matter for export of this mesh. Right click and export. As a CSV. The output name, we just add out and say OK. And now it's being created inside of Alpine Model actually. I'm going to take a copy of that and put it outside and change the extension to .dat. And now the next job is to open FEFLOW again. With FEFLOW open now, returning to the map panel, and we right click in the background and say add map. We browse to the newly created file and open. Once it loads here, we need to right click and define coordinate fields. The large file is loading. Next we need to map the coordinate fields. X is center X, Y is center Y, Z is center Z. OK. Again in the map panel we're selecting the filled file and we're going to right click and say link to parameters. We're going to associate the current model grid with our geology from GeoModeller. Double clicking creates the link. And now in the properties table, the elemental layer is field containing element number, and then element. In the maps, we're going to double click to activate this in the 3D viewer. Then we're going to select all, and finally use the green tick to import the data from the map into the geology parameter of the mesh. And then clear the selection. There we have it. All done with geology patches introduced now to the pre-existing finite element mesh.